Faster than light, travel, the holy grail of space exploration, the only hope we have to explore space as much as we want. However, will humans ever travel at the speed of light? New research says yes. A possible solution to the problem of traveling at the speed of light or even faster is the warp drive, popularized by Star Trek, the sci-fi franchise still ongoing. Therefore, if we could find a way to bend or warp space-time, we would be able to move around the cosmos in the blink of an eye. Warp drives have mostly remained the preserve of science fiction. However, a number of new discoveries by a German physicist about the nature of space and time imply that Einstein's purportedly unbreakable speed limit may not be so unbreakable after all. Does that mean it's possible to travel faster than the speed of light by warping space-time? And in doing so, have we also discovered the key to exploring the universe? Light is the fastest thing to ever occur in the universe. However, this truth has not always been known. In ancient times, many scientists believed the speed of light was infinite and could travel any distance instantaneously. The Italian physicist Galileo Galilei was among the first to try to measure the speed of light. In the early 17th century, he devised a very crude experiment in which two people with covered lanterns stood a known distance apart. One person uncovered his lantern, and as soon as the other person saw the light, he uncovered his lantern. Galileo attempted to record the time between lantern signals, but, as you can imagine, he was not successful because the distance involved was too small and light simply moved too fast to be measured this way. Around 1676, Danish astronomer Ole Romer became the first person to prove that light travels at a finite speed. He studied Jupiter's moons and noted that their eclipses took place sooner than predicted when Earth was nearer to Jupiter and happened later when Earth was farther away from Jupiter. Romer reasoned this was the result of light moving at a finite speed. It took longer to make it to Earth when Jupiter was a greater distance away. French physicist Hippolyte Fizeau is credited with making the first non-astronomical measurement in 1849, using a method that involved sending light through a rotating toothed wheel and then reflecting it back with a mirror located a significant distance away. One of the first precise calculations of light's velocity was made in the 1920s by American physicist Albert Michelson using his 8-sided rotating mirror apparatus. In 1983, an International Commission on Weights and Measurements set the speed of light in a vacuum at the calculation we use today, 299,792,458 meters per second, or 186,282 miles per second. At that speed, you could circle the equator 7.5 times in a single second. However, traveling at the speed of light is a huge leap from discovering the speed of light. Humanity would have to wait centuries before seeing that happen. But what exactly does it look like to travel at the speed of light? What is the experience like? You would move very fast, but that might be the only nice thing about it. Just forget about anything creeping up behind you, because since the light behind you cannot catch you, it will most likely go dark behind you. So if a deep space monster is gaining up on you, there is no way to know. Light to the sides of you is likely to streak past in lots of bands of color. It will likely be like when traveling fast on the road and the trees in front slowly arrive, then swoosh past in a blur. Expect this phenomenon to be highly exaggerated at such high speeds. Light in front of you will be coming quicker than normal and thus will be bright and intense. Things will also appear to go quicker, so you'll see a distant planet spin quicker than normal as you move closer to the light reflected off it. Your field of view would also narrow, and if you wonder how, just ask a race car driver. But that is not all, because speed of light travel affects your body physically. Remember E equals mc squared? Well, you can't escape it, so you gain mass as you go faster. This is because atoms fill up with energy. This means as you get faster and faster, you will grow personally more massive, and your muscles may stop being strong enough to support your increase in mass, so you would sink to the floor unable to move. Meanwhile, your ship is affected too. Since it is most likely made of different metals, as the ship gains mass, the ship's parts may all grow at different speeds. Each atom has a different mass and setup, so will expand at different rates. If this is the case, your ship at light speed may start to come apart and vent air and fuel. So it is possible that as your ship gets faster and faster, it begins to just fall apart around you. There is still another complication: time dilation. Time dilation is an actual difference of elapsed time between two events as measured by observers either moving relative to each other or differently situated from gravitational masses. This is why astronauts returning to the International Space Station have traveled 0.007 seconds into the future after spending 6 months in orbit. Of course, they haven't traveled forward in time, they just aged slower relative to everyone on Earth. So let's use Alpha Centauri as an example. We will assume you can instantly accelerate to 99.9% the speed of light, as well as instantly deaccelerate without killing yourself or destroying your ship. Alpha Centauri is technically 4.5 light-years away, but for ease of calculation, we will use the value of 4. Traveling at 99.9 C for 4 years in Earth time means you'd experience a trip of about 2 weeks or 14 days. Everyone on Earth will have aged 4 years, but you will have aged only 2 weeks. To imagine this dilation effect for this particular effect, you can think of it one of 2 ways. Either time on the ship is moving 110 times slower than normal, or you're traveling a distance 110 times shorter. As far as space-time is concerned, it is the same thing. Of course, you still have to communicate with your mission command center, but communication from that distance means any signal you send, and we are assuming it was powerful enough to be heard and understood, would take 4 Earth time years to get back to Earth. So it's probable that you'd show up in the system, do science for a year or so, likely sending some type of signal to Earth to let mission control know you're still alive, even if you can't transmit usable data, then return to Earth. You will have been gone for a total of 9 Earth years and about 1.24 years of your time. Despite all the scary scenarios and consequences, speed of light travel is the only way we can explore even the nearest star if we want to send astronauts or other humans or probes there. Scientists will jump at the opportunity despite possible negative effects. Before we dive into how we can achieve speed of light travel, what are the fastest human-made objects? Bullets can go 2,600 miles per hour or 4,200 kilometers per hour, more than 3 times the speed of sound. The fastest aircraft is NASA's X-3 jet plane with a top speed of 7,000 miles per hour or 11,200 kilometers per hour. That sounds impressive, but it's still only 0.001% the speed of light. However, the fastest human-made objects are spacecraft. The spacecraft that is traveling the fastest is NASA's Parker Solar Probe. After it launched from Earth in 2018, it skimmed the Sun's scorching atmosphere and used the Sun's gravity to reach 330,000 miles per hour or 535,000 kilometers per hour. That is blindingly fast, but it is only 0.05% of the speed of light. But how can we achieve speed of light travel? In science fiction movies, there are many examples of spaceships racing through space at the speed of light or faster. But a new research paper written by an American physicist has proposed a theory for how faster-than-light travel could be possible. The research was carried out by Eric Lenz, who did the work at the German University of Göttingen. Lenz and his team believe that travel to distant stars and planets could be possible in the future, but this can only happen if space vehicles travel faster than the speed of light. The latest research on the subject has centered on theories beyond normal explanations of matter. They call for hypothetical particles and states of matter with unusual physical properties to permit faster-than-light travel. This kind of matter either cannot be found or cannot be manufactured in necessary amounts, the paper states. The new paper places more importance not on theoretical research, but a possible engineering solution. The research describes a plan to permit superfast travel by creating a series of what the researchers call solitons to provide the basis for a powerful propulsion system. A soliton is a compact wave that keeps its speed and shape while moving with little loss of energy. The research suggests that such a method could permit travel at any speed. The results recently appeared in the publication Classical and Quantum Gravity. The method uses the very structure of space and time arranged in a soliton to provide a solution to faster-than-light travel, said a press release explaining the process. Lenz told Reuters news agency that such a warp drive technology could be used to sharply reduce travel times. That could make future travel to distant space objects possible. Lentz said that using traditional rocket fuel, it would take about 50,000 to 70,000 years to reach Proxima Centauri. A trip using nuclear propulsion technology would take about 100 years, but a light-speed trip using his invention would take only 4 years and 3 months, since it will travel at the speed of light. Lentz said a lot of work will be needed to make the method become a reality. To be useful, it would require lowering the energy needed down to the level of modern nuclear power reactors. A way to develop and speed up the solitons must also be created. Let's hear what you think of speed of light travel in the comments section below.